Hello, and welcome to the Demoette series for TIBCO Data Virtualization, or TDV. Demoettes are brief instructional videos that demonstrate specific features of TDV. In this demoette, we discuss using JMeter to perform load testing on TDV virtual databases via JDBC. Here is our agenda. We begin by defining JMeter load testing and outlining its importance for our customers. Next, we walk through a very basic demo of using JMeter with TDV JDBC resources. Finally, we summarize the contents of this demoette. Let's begin by discussing what JMeter is and why it is important for our customers. JMeter is an Apache open source project that offers a comprehensive load testing solution. It may be used to perform load testing for functional behavior as well as performance management. JMeter supports many different servers and protocols. In this demoette, we concentrate on using JMeter to load test TDV JDBC resources. JMeter is important to our customers because they often need to understand the performance characteristics of TDV before purchasing the product or before committing to large new projects. JMeter load tests can help customers develop their hardware requirements. It can also help them identify project resources that may require tuning or other design considerations. Next, let's walk through a very basic demo of using JMeter with TDV JDBC resources. Here is the business problem that we illustrate in this demo. Prospective customers of Cisco Data Virtualization often ask, how much overhead does TDV add to a query? To answer this question, we'll take timings of queries against a SQL Server database table. Then we'll publish a TDV view of the same table and take timings of queries against TDV. We'll use JMeter to simulate concurrent user load. Let's stop a minute though and ask if this is really a meaningful question. The answer depends on the customer's use case. For most customers, the main value of TDV is its ability to federate data from multiple sources in an agile manner with data that is current. For these customers, the test above has little meaning. They use TDV because the alternative is either manual data wrangling or traditional ETL processing. Manual data wrangling can cost days of human effort, with concomitant loss of data concurrency. ETL can also result in days of lost data currency. Both alternatives also suffer from poor agility in the face of ongoing change requests. For these use cases, it is much more meaningful to ask questions like, how much time does TDV save compared to manual processing? Or what is the value of serving up to the second data as opposed to ETL data from last night? Or how much money will I save if I can respond to change requests in days instead of months? However, there are some TDV use cases where the test shown here is meaningful. Some customers use TDV as a central front door for enterprise data access. They may choose to expose data from physical sources unchanged. This approach can be useful for highly expert end users who are capable of designing and implementing their own joins. In this use case, TDV adds value by serving as a central point for authentication and authorization. Begin by going to jmeter.apache.org and learning about JMeter. JMeter is a very rich and sophisticated product, and we can only scratch its surface in this brief demo. You can download JMeter from this site and install it. Installation is very simple. Just extract the download to a directory of your choice. One important installation note is that Apache recommends that you install JMeter in a directory path which does not contain any spaces. Next, you will need a physical data source. In this demoette, we will be using SQL Server instance on a public website. However, we do not make this database available for general use because we do not want to expose the password. You can use a table from any physical database available to you. Next, create a TDV view using the table from your chosen database. You will need JDBC drivers for your chosen physical database, as well as for TDV. The TDV driver, csjdbc.jar, is found in the path shown here. Place both drivers in the lib directory of the JMeter installation. JMeter will automatically find them from this directory. When considering any load testing, it is essential that everyone involved be aware of the need to plan and scope the effort. You can't just fire up 10,000 simulated users on your laptop and expect to get realistic results. If you did this, you would simply surface limitations that are not related to what you are trying to test. For example, a load this big on a single client machine would likely overwhelm its available CPU, RAM, and disk resources. In addition, this setup would probably cause artificial network problems. The client machine's network interface card would likely be overwhelmed. Even if you spread the load across several machines on a single LAN, you would likely have an artificial situation because a LAN is a broadcast zone for IP messages and would create a flood of packets that differs from a more real-world situation where users are spread across several LAN boundaries. A heavy load on a single client can also surface JMeter limitations. For example, JMeter runs each simulated user on a thread, and it is susceptible to an issue known as coordinated omission. If a thread cannot complete a task before its next task is scheduled to begin, it simply skips the next task, which means that the total load will be smaller than expected. It is also important to consider the design of the TDV resource requests to be tested. For example, if you have a resource that is usually filtered with a where clause, you may get unrealistic results if every simulated user submits the same filter. JMeter has capabilities to deal with all of the above issues. You can design tests that use a fleet of remote client machines, and you can vary query parameters across simulated users. However, you could easily spend months in the design, construction, execution, and analysis of the perfect test. When time and resources are constricted, don't let the perfect be the enemy of the good. Start small and take basic load measurements. Then make your test plans more sophisticated as time and resources permit. Now we're ready to use JMeter. To start it on Windows, run jmeter.bat from the JMeter installation directory. A console window appears, followed by the user interface. The test plan is the highest level object. Begin by renaming it as shown here. Note that JMeter editors do not have a save button. Your work is automatically saved as you make changes. However, you will need to save your test plan project when you are all done, so that it can be reloaded later. You can do this from the File menu. To build a test plan, we add a series of child objects to the top-level test plan object. Right-click the test plan and select Add, Threads, Thread Group. This will let us define our simulated end users. The Thread Group editor appears. You can rename that thread group, but this is optional. I have defined 5 users. I tell JMeter to ramp up all 5 users in a total time of 1 second. I want each user to execute 10 iterations of whatever workload I define. Now right-click the thread group, select Add, Config Element, JDBC Connection Configuration. Here we can specify the details of the JDBC connection. Choose any name you like for the connection pool. We'll use this name later when we define specific queries. Provide the JDBC connection string, driver class name, user ID, and password. At this point, we have defined all the general information for the thread group. Now we can define the specific requests. Right-click the thread group and select Add Sampler JDBC Request. For our first request, enter the connection pool variable name we defined earlier and add a SQL query. This query selects all our California customers. Then create a second JDBC request. This one is identical to the first, except that it selects New York customers. We are ready to try out our load test, but first we need to define a way to gather the results. Right-click the thread group and select Add Listener Graph Results. Leave the default settings for the graph listener and click the Run button. Graph results are shown for all the selected measures. Summary information is provided at the bottom of the screen. Note that there are 100 samples. That's because we have 5 users. Each is running a query for California and another for New York, and each user is looping through the tasks 10 times. If you press the Run button repeatedly, the graph results accumulate. Here are the results after 1,000 samples. The graph results listener is great for initial functional testing, but it is not recommended for actual load testing because this listener is very resource intensive. Let's look at some other listeners that are more appropriate for load testing. First, right-click the graph results listener and disable it. Now, right-click the thread group and select Add Listener Simple Data Writer. The Simple Data Writer is a good listener for an actual load test because it is not resource intensive. You can use the Browse button to define a CSV file to hold the test results. This error message simply means that the file does not already exist. Don't worry, JMeter will create it when you run the test. Run the test and then open the CSV file you defined. We can see that the tasks were successful, and we can learn about the timings. The summary report is another listener choice that is also modest in resource consumption. It produces a useful summary of aggregated results. It also records detailed information in the CSV file, much like the Simple Data Writer. Now we can test access through CIS. Do a save as and rename the original test plan so we can use a new version for CIS access. We'll make just a few changes to the original plan. First, create a new variable name for the connection pool to avoid any confusion. Next, change the connection details as shown here. Now change the first JDBC request. Use the new connection pool variable. Change the query to name the TDV table in the From clause, and remove any square brackets that were used in the SQL Server query. Do the same for the second query. Now we can run the test against TDV and compare the results. For this demo, we'll simply look at the overall averages. The direct queries to SQL Server ran in an average time of 131 milliseconds each. The requests through TDV ran in an average time of 150 milliseconds each. That's 19 milliseconds longer, on average, for queries running through TDV. This will be imperceptible to end users. In this presentation, we've only scratched the surface of JMeter's capabilities. However, we have shown how to create a simple but meaningful load test of TDV JDBC resources and demonstrated several ways to view the test results. Our demo is complete. Let's summarize what we've seen in this presentation. JMeter is an Apache open source project that offers a comprehensive load testing solution. It may be used to perform load testing for functional behavior as well as performance management. JMeter supports many different servers and protocols. JMeter is important to our customers because they often need to understand the performance characteristics of TDV before purchasing the product or before committing to large new projects. JMeter load tests can help customers develop their hardware requirements. It can also help them identify project resources that may require tuning or other design considerations. Thank you.